Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My dear friends, today I introduced about the city of Mangla, the historical place of Mangla Dam. First of all, I introduced the Mangla project. The Mangla project was developed after Pakistan and India signed the Indus Water Treaty in 1960 that gave Pakistan rights to the three western rivers of India, the Jhelum, Chenab, and the Indus. Mangla was the first of two dams built to strengthen Pakistan's ability to irrigate its crops. The Mangla Dam is a multi-purpose dam on the river Jhelum in the Mirpur district of Pakistan. The seventh largest in the world, the dam is named after the nearby village of Mangla. It is used for irrigation and producing hydroelectric power. The scheme was designed by London firm Bani and partners led by engineer Geoffrey Bani and IEC fellow. The structure was built to give farmers in Pakistan more water during critical growing seasons. Before the dam's construction, the country's irrigation system was dependent on the unregulated flows of the river Indus and its tributaries. Pakistan's agricultural output was very low, often because there was not enough water to irrigate fields while crops were growing. Things were often made worse by flooding during monsoon season and a lack of reservoirs to store water when rivers were high. The Mangla project was developed after Pakistan and India signed the Indus Water Treaty in 1960 that gave Pakistan rights to the three western rivers of India, the Jhelum, Chenab, and Indus. Mangla was the first of two dams built to strengthen Pakistan's ability to irrigate its crops. The other was the Tarbela Dam on the river Indus. Mangla Dam. The Mangla Dam project in northern Pakistan is one of the greatest reservoirs projects of the 20th century. Investigations and design started in 1957, and today in 2018 Alex Helmington talks about the project he worked on. These are some pictures showing the Mangla Dam. Mangla is a town situated in district Mirpur within the region of Azad Kashmir. The village is located in the west of the foothills of Mangla's fort, which also derived its name from the same village. It is surrounded on three sides by the semi-curvature of river Jhelum, following north to south. It is bordered with Jhelum district and with the right bank of Mangla between the state of Azad Kashmir and Punjab province of Pakistan. Etymology. Mangla Dam. Etymology. The town of Mangla was named after Mangla Devi, Kokar Rajput tribe lady. Mangla Devi was the daughter of Kokar Kshatriya Raja Porus. It has been narrated to be the site of the crossing of Jhelum River by the forces of Alexander the Great facing King Porus. History of the Mangla Dam. History. At the time of construction of the Mangla Dam, the villages of Sultanpur, Til, Varal and Baruti across the river in Jhelum district were developed as residential colonies. and emphasis for foreign workers and officials. Prior to the construction of Mangla Dam in March 1962, almost all the inhabitants of the ancient Mangla village moved to Mangla hamlet. Therefore, this town represents Mangla in a true sense. Mangla is located 12 km 7.5 mile from the city of Mirpur at the mouth of the Mangla Dam. The dam reservoirs has a perimeter of 400 kilometers and is a place of interest. It hosts the Mangla power station, which is the second largest in Pakistan. Mangla Fort. Mangla Fort in Mangla Dam. Mangla Fort. Mangla is the site of historic Mangla Fort. The fort is situated on a high hill overlooking the Jhelum River, dividing the Mirpur and Jhelum districts. A part of Mangla Fort was razed during the construction of the Mangla Dam. However, a large part remains and serves as a public recreation place. There are some pictures of the Mangla Fort. This scene shows this fort is constructed in a very beautiful place. Mangla Dam. The Mangla Dam is a multi-purpose dam situated on the Jhelum River in the Mirpur district of Azad Kashmir, Pakistan. It is the sixth largest dam in the world. The village of Mangla, which sits at the mouth of the dam, serves at its namesake. In November 1961, the project's selected contractors were revealed. It was announced that Banyan and Partners, a British engineering firm, was going to serve as the lead designers, engineers, and inspectors for the construction of the dam, led by Geoffrey Benny. The project was undertaken by a construction known as the Mangla Dam constructors, contractors, which consisted of 8 American construction firms sponsored by the Guy F. Atkinson Company based in South San Francisco, California. As part of the Indus Water Treaty signed in 1960, India gained rights to the waters of the Ravi, Sutlej, and Beas rivers, while Pakistan, in addition to the waters of the aforementioned three rivers sections within Pakistani territory, and some monetary compensation, received the rights to develop the Jhelum, Chenab, and Indus River basins until 1967. The entire irrigation system of Pakistan was fully dependent on unregulated flows of the Indus River and its major tributaries. The agricultural yields was very low for a number of reasons. The most significant begins a lack of water during critical growing periods. This problem stemmed from the seasonal variation in river flow due to monsoon and the absence of storage reservation to conserve the vast amounts of surplus water during those periods of high river discharge. The Mangla Dam was the first of the two dams constructed to reduce this shortcoming and strengthen the irrigation system of the country as part of the Indus Basin projects, with the other being the Tarbila Dam, situated on the Indus River in Swabi, Khyber Pakhtunkhwa. Construction Mangla Dam. The Mangla Dam was constructed at a cost of Pakistan rupees 15.50 587 billions, USS 1.473 billions, with funding being provided by the World Bank and the Asian Development Bank. The dam was constructed between 1961 and 1965 across the Jhelum River in the Mirpur district of Kashmir. About 108 kilometers 67 miles southern of the capital city of Islamabad. The Mangla Dam components include a reservoir's main embankment, intake embankment, main spillway, emergency spillway, intake structures, 5 tunnels, and a power station. Beside the main dam, a dike called Sukhiya, 17,000 feet, 5,200 miles in length, a small dam called Cherry Dam to block the Cherry Nala, about 11 miles behind the new Mirpur. There was a total of 120 by 106 cubic yard of excavation for the reservoirs, whereas the total fill amounted to 142 by 106 cubic yards and concrete to 1.96 by 106 cubic yards respectively. The main embankment is earth fill with clay as the core material. Gravel and A-type sandstone are applied on the shoulders. The maximum height of the embankment above the core trench is 454 feet 138 millimeters and the length is 8,400 feet 2,600 meters. The intake embankment is earth-fill type with B-type sandstones as the core material. Gravel is applied on the shoulder. The maximum height of the intake embankment above the core trench is 262 feet 80 meters and the length is 1,900 feet 580 meter. Sukhiya Dam is earth-filled by B-type sandstone as the core material. A-type sandstone is applied on the shoulders. The maximum height of the intake embankment above the core trench is 144 feet 44 meter and the length is 16,900 feet 5,200 meters. Jerry Dam is also an earth-filled type with silt as the core material. Gravel is applied on the shoulders of the dam. The maximum height of Jerry Dam above the core trench is 274 feet 84 meter and the length is 6,800 feet 2,100 meters. The main spillway is a submerged offices type with 9 radial gates 36 feet 11 meters 40 feet 12 meter each. It has a maximum capacity of 1.1 million cubic. The emergency spillway is a wire type with an erodible bond and a maximum capacity of 0.23 million cubic. These 5 tunnels are steel and concrete lined and 1,560 feet long in bedrock. The internal powerhouse Mangla Dam. The powerhouse, which consists of turbines, generators, and transformers, has been constructed at the toe of an intake embankment at the ground surface elevation of 665 feet SPD. The water to the powerhouse is supplied through 5 steel-lined tunnels of 626 feet diameter. Each tunnel is designed to feed 2 generating units. The powerhouse tail race discharges into New Bong Canal, which has a length of 20,000 feet with a discharge capacity of about 49,000 success and terminates at an automatic gate control headworks at about 12 km downstream, located near Old Bong Escape Headworks. Powerhouse, a picture of the powerhouse of the Mangla Dam. There are 10 vertical Francis type turbines in the powerhouse. Each of these turbines has an output of 13,800 bphp with a rated head of 295 feet of water. The first 4 turbines were manufactured by Mitsubishi Electric Japan and were installed in 1969. Turbines 5 and 6 are manufactured by CKD Blansko. The Czech Republic and were installed in 1974. Turbines 7 to 8 were manufactured by ACEC Belgium and were installed in 1981, while the remaining two turbines were a make of Sakura, Czech Republic and were commissioned in 1994. These turbines are connected to umbrella type generators which have a generation capacity of 100 MVH. Hitachi Japan had provided generators for turbines 1 to 4 and 7 to 8, while Sakura generators are connected to the turbines 5 to 6 and 9 to 10. These generators are in turn connected to three-phase transformers. The transformers connected to turbines 1, 4 and 7 were manufactured by the Italy-based Saviglio. The transformers for turbines 5 and 6 are a make of Ital Trafo and other Italian company, while the remaining 5 transformers were provided by Sakura. At the end of the introduction of the Mangla Dam and the place of Mangla, please like and subscribe. Thanks for watching. Please like so that my all videos incoming will be available to you on my channel. Thank you very much, my dear friends, for watching.